Right, in today's lesson 6.4 with the nth roots, our two goals are to simplify radicals, and the second goal is to use a calculator to approximate radicals. Pascal 1.1a and b, which states that we should be able to convert expressions from radical notation to rational exponents and vice versa, which will come later, and then to add, subtract, multiply, divide, and simplify radical expressions. So the simplification is really what we're touching on today mostly. Okay, basically, let me back up here a second and show you what we're talking about. Go to a blank page, and let's just do this. Okay, because 3 squared is 9, that implies that the square root of 9 is 3. Okay? But what if we had 3 to the third power, and we wanted to figure out, what number could we take to the third power to get 27? All right, well then what we would need to use is a third root of 27, and that equals 3. Suppose that I have, let's say I've got 2 to the fourth power. That's 2, 4, 8, 16. Okay, let's suppose I want to go back and figure out this. The fourth root of 16 is 2, because 2 to the fourth power is 16. And that's really what we're talking about when we're talking about nth roots. We're talking about third roots, fourth roots, fifth roots, and so on. Okay, so that's all we're talking about right here. Our definition of nth root is for any real numbers a and b, and any positive integer n. If a to the n equals b, then a is an nth root of b. Okay, so that's the definition that we're working with there. All right, when you're dealing with roots, this number that you see right there is an index. We call that the index. And, of course, you've got your radical sign and your radicand. Okay, so if you don't see the index, we're talking about basically the square root. Now, when I look at something like the square root of 9 equals 3, that's because 3 squared equals 9, but doesn't also negative 3 squared equal 9? So this thing really has 2 square roots. So to keep from any confusion happening, if we don't put a sign in front, then we want the positive answer. And so the square root of 25 is 5. That's the positive version. We call that the principal version. If we put the negative sign in front, then we want the negative version. If we put plus and minus in front, then we want both versions. Okay, now, if we are looking here at something like the nth root of a, let's take a look at this. As long as this is a positive number and this is even, okay, then you're going to have a unique positive and a unique negative real root. So you'll have a positive and negative, and the positive root is considered the principal root. Now, if this is odd, then you're just going to have one positive and no negative roots, okay, as long as a is positive. Now, if a is negative and this is an even number, you're not going to have any real roots. If a is negative and this is an odd number, you're going to have one negative root of the thing. And of course, if a is 0, then it's only going to have one real root no matter what. So let's jump into this. Okay, here we want both roots of, both square roots by the way, of 16x to the 8th. Okay, so we're looking for the positive and negative. Alright, now 16 is 4 squared. So we're looking at the square root of 4 squared x to the 8th. Basically, all you got to do is take this power and divide it by this power. So we're looking at positive and negative. 4 squared, the square root of, is 4. The square root of x to the 8th is x to the 4th. And that one's finished. In this one, we're looking for the negative root, negative square root. Okay, now, I'm looking at this and I'm going to think of this as just a number. Q to the third plus 5. Alright, so the square root of a fourth root, of something to the fourth power, would be to the second power. So, the negative square root of q to the third plus 5 quantity to the fourth power is negative q to the third plus 5 squared. Let's kick it up a notch here and let's look at this. 243. Okay, we're looking at the fifth root. You have to factor this to see what it really is. 243 is actually 3 to the 5th power. So I have 3 to the 5th power times a to the 10th power times b to the 15th power as my radical. And so in order to do this, I don't need to worry about positives and negatives here because that's an odd. So the 5th root of 3 to the 5th power is 3. The 5th root of a to the 10th is a squared. And the 5th root of b to the 15th is b to the 3rd. All right? And last but not least, we covered these before. When you have like the square root of a negative number, you're going to have two answers in this case. And the square root of 4 is 2, and don't forget about that I. That will happen from time to time. All right, so that's my first example for you. My second example has to do with absolute value coming into play. When you find an even root of an even power and the result is an odd power, you must use the absolute value of the result to ensure that the answer is non-negative. Look at this, for example. Let's suppose that I have the square root of x squared. Now, from previous examples, we would say that that is x. But what if x were a negative number? For example, what if x were negative 3? What would happen here? Okay? Then what we would have is the square root of negative 3 squared. Now, that is the square root of 9, which is 3. But that's not what we started off with originally. So, to make this thing work, whenever we got an even power, and that's an even number, and we come out with an odd power, we've got to remember to use our absolute values, because the absolute value of negative 3 is 3. So just another example here. Let's suppose that I had the square root of x to the 6th power. Then doing the math on this, 6 divided by 2 is 3, so that'd be x to the 3rd power. Since this is even and this is even, I need to use, and this is odd, I need to use my absolute values. Now, on the other hand, let's suppose that I had something like this. Let's say I have x to the 10th, and I want to do the 5th root, okay? Well, when I do my math here, that's going to be x squared. Now, since this is even but this is odd, I don't need to worry about absolute value, all right? Or if at any time, for example, I've got x to the 8th, 4th root of x to the 8th, this would be x squared. They're all even. I don't need to worry about absolute values. So, looking at this one, let's do the math first. The 6th root of t to the 6th is t to the 1st. Even, even, odd power, I need absolute value. Okay, let's look at this one. 243, we already know is 3 to the 5th power. Okay, so I'm looking at the 5th root of 3 to the 5th power, which is 3. Then this number, all right, this is the 5th root of that number to the 15th power. 15 divided by 5 is 3. Okay, this variable contains a variable, but it's to an odd power with an odd root. I don't need to worry about absolute values on this one. Okay, now the last thing in today's lesson is approximating square roots on these. Just a real simple little thing. Let's say that I've got the 5th root of 27.6, and I want to take this out to 3 decimal places. Okay, doing that, just get your calculator open. Okay, open the calculator screen, and what was I looking at? The 5th root of 27.6. So we'll need to go to this button right here, put a 5 as our index, and we're looking for 27.6. Alright, so go over there, 27.6, push enter. Now to take this out to 3 decimal places, that's going to be 1.942. 1.942. We use the approximate symbol because this is not the exact answer. So it's approximately 1.942. That's today's lesson. Tomorrow we'll begin working on lesson 6.5.